In today's lesson, we'll be learning about the method of substitution. In our first example, we want to solve by substitution. Solving a linear system means finding the point of intersection of these two lines. Our first line, which is in red, is in standard form. Our second line, which is in blue, is also in standard form. I want you to examine these two equations very carefully. You need to ask yourself the question, are there any variables that have been isolated? As you can see, no variables have been isolated in either of these two equations. So you need to do that. I'm going to choose the red line first because it's a little bit more simple to work with. I'm arbitrarily going to choose to isolate the variable of y. If I want to isolate y, I need to get rid of the variable of x, which is beside it. So I need to do the opposite operation to both sides of the equation, which means I'm going to subtract both sides by x. X minus x cancels out, which leaves me with just y is equal to 5 minus x. As you can see, the y is now isolated, which means I can replace or substitute in this expression for y. Before I begin, I'm going to label the red equation, equation 1, and the blue equation, equation 2. I'm also going to make a quick note to myself to remind me that I have isolated y already. Next, I'm going to substitute equation 1 into equation 2. Which means I am replacing the y in equation 2 with the expression I found earlier, which was 5 minus x. I want to simplify both sides of the equation, which means I need to use the distributive property to distribute a -1 to everything in the brackets using multiplication. Therefore, the 3x stays the same. -1 times 5 is -5, and -1 times -x is positive x. What I'm going to do next is identify like terms. 3x and positive x are like terms. Therefore, I'm going to rewrite my equation such that like terms are beside each other. 3x plus x is 4x. Remember, we want to isolate x, but x is stuck with a multiply by 4 and subtract 5. To get rid of the subtract 5, I need to add 5 to both sides of the equation. -5 plus 5 cancels out, which leaves me with just 4x, and 7 plus 5 is 12. To get rid of the multiply by 4, I need to divide both sides by 4. The 4's cancel out, which leaves me with just x is equal to 12 divided by 4, which is 3. Therefore, I've just determined the x-coordinate of the point of intersection, and it is x is equal to 3. Before we begin, I just want to relabel this equation 1 and that equation 2, and I want to make a quick note that I've already isolated y, and that is y is equal to 5 minus x. I'm now going to take the value of x and substitute it into one of these two equations. It doesn't really matter. Since I've already isolated y for equation 1, I am going to substitute in x is equal to 3 into equation 1. Let's begin with the equation, which is y is equal to 5 minus x. So I'm just going to replace x with 3 in brackets. Therefore, 5 minus 3 is 2. And now I have the y-coordinate of my point of intersection. Therefore, the solution or point of intersection is 3, 2. I need to check that this coordinate lies on both lines. Therefore, I'm going to substitute in this coordinate into both lines and do a left side equals right side check. So let's begin by relabeling our lines 1 and 2. I am going to say sub 3, 2 into equation 1. So I'm going to begin with x plus y is equal to 5. I'm going to replace the x with a 3, and I'm going to replace the y with a 2. The equal 5 stays exactly the same, and 3 plus 2 is 5, and the other side is 5. Therefore, the left side is equal to the right side, which means this point lies on this line. I'm going to do the exact same thing with the other line. So I'm going to sub coordinate 3, 2 into equation 2. Let's begin with our equation, which is 3x minus y equals 7. I'm going to replace x with the number 3, and I'm going to replace y with the number 2. The equal 7 stays the same. 3 times 3 is 9. That's negative 2. 9 subtract 2 is 7. So 7 is equal to 7. Therefore, the left side is equal to the right side, which means the point lies on the line. Let's make a concluding statement. Since left side is equal to right side for equation 1 and equation 2, therefore, the solution is indeed 3, 2.